Here we have another synthesis problems. We need to synthesize this compound from this one. So what are the reagents that we need? So again, strategy, we always need to note how many carbons we have in the product and in the reactant. And what I see here is that I have, here is from the ring, I have 1, 2 carbons, and here I have 1. So I have 1 less carbon. So what reaction do we know that I've removed carbons atoms? So we know that this could come from the ozonolysis of an alkyne. So if I think backwards, so my retrosynthetic analysis, let's do the arrow in that direction. What do we have? If I draw an alkyne here in 1, 2, and 3. And now I will have 1 more carbon, but certainly if I do the ozonolysis of the alkyne, remember that I will have a carboxylic acid and carbon dioxide. So we will form those two because it is a terminal alkyne. All right, so once I have figured out how can I have 1 less carbon by doing this reaction, I need to synthesize. Now I'm coming from here to here. So what steps do I need to do? Now I need to make an alkyne, and I have an alkene. And I know that alkynes can be made from elimination reactions of, say that I have a couple of ways. If I have this, dihalide or geminal, in which case will be, say, bromine. Yeah. I can do a double elimination, so bromine. If this is, say, geminal or vicinal, so vicinal, geminal, I can make with either of these two with excess of sodium amide, I can make an alkyne, and this will be 2 consecutive E2. So twice we're gonna do an elimination of HBr. So minus HBr, but I'm doing that twice. So that's how I can make that. So backwards, then I need to make a dihalide from this one and then perform the elimination. So what that means is that I need a bromination reaction. So the bromination reaction of the alkene is gonna give me what I need. So I'm gonna have a bromine here and another bromine here. And now by doing sodium amide, let's just do one of the elimination steps. We will have this. Remember that every time you will have hydrogens here. So if we do, let's just draw the hydrogens. 1 hydrogen here. We'll make a double bond, double B and E2 elimination. You make an alkene. And then because we're using excess, so excess sodium amide, first you're making your alkene. But that alkane will still have a bromine and another hydrogen. So again, sodium amide. So 2 consecutive elimination, you will form an alkyne. And then doing ozonolysis of the alkyne will remove that extra hydrogen. So bottom line, what do we have? What type of analysis we did? We noticed how many carbons we have here and here. I have 1 less carbon. The way to remove 1 carbon and make a carboxylic acid is doing the ozonolysis of an alkyne, which we know will produce carbon dioxide. That's one of the carbons in that carboxylic acid. And thinking backwards, how do we make an alkyne from, there's a couple of strategies here. Either using a vicinal, so neighboring carbons having halides, or geminal. And from that alkene, I know I can make a dihalide, and that's the case here. I have bromine and bromine, And I have added that by making the addition reduction, the alkene and bromine, you do the halogenation here, and then with excess of sodium amide. So summarizing, what is the reagent? From this, first step will involve a bromination reaction. Say that you do that with carbon tetrachloride. Second step is treat that with an excess of sodium amide. And when we use an excess of sodium amide, typically we form, and let me draw that something here. We will make an ion, so we need to add acid to actually isolate the alkyne. So I'm going to do H3O plus. And last step will be the ozonolysis to remove that. So this is how we will do the synthesis of that compound.